Alright, in this video we're going to discuss the first way of solving a solution to a system of equations. The best way to solve a fairly simple system is to solve it by graphing. A solution to a system is essentially saying what point will satisfy both equations in the system, or if you had multiple equations, what point would satisfy all equations in the system, which on a graph will be the point of intersection, the point that is on both lines or all the lines within the system. So let's start with the equations over here at the left. Y equals -4, remember, is a horizontal line. So what we can do is go down to y equals -4 and just draw in a nice horizontal or fairly horizontal line down at -4. For the second equation, notice that we're in y equals mx plus b, the slope being -2 and y-intercept being -2. So we can start off at -2, go down 2, right 1. And you'll notice we get that nice big point of intersection right there. Or we could have gone up 2, left 1. But we don't really need to, as we notice that they're going to cross at the point 1, -4. And a great idea is to plug that point back into your equation. Notice that y being -4 definitely satisfies the first equation. And if we double check it in the second equation, -4 would be equal to -2 times 1 minus 2, which essentially creates -4 equals -2 minus 2 is -4, and that checks. So there's your solution to your system, the point at 1, -4. The second set of equations, notice, is not in y equals mx plus b form, but that's not going to stop us. Remember, you can always use intercept points to get a fairly simple line. Now, it probably won't be quite as accurate as using the slope, but again, once we've got two intercepts, we can judge the rest of the line on the graph. So if I plug in 0 for x in the second equation, notice that's just going to disappear, and y ends up being equal to -3. Then if we go back and cross out the y, -x equals -3. When y was 0, essentially disappearing, divide by -1, x is 3. So we can get a fairly simple point at 3, 0, a point at 0, -3, and a nice straight line traveling through those points. And you'll notice that since we went up 3, right 3, we definitely had a slope of 1, which can help you find lots of other points on your graph. Let's go ahead and do the first equation the same way. So if we plug in 0 for x, notice that 3x will disappear, and if we divide by 6, y is 3. Also, if we plug in 0 for y instead, so go back and move that scribbly line over here, divide by 3, we get a point up at 6. So what we can do then is travel up to 6, 6, 0, right here, a little bit out there, and 0, 3, and then try to connect the line as smoothly as we can. Now notice if we go down 3, right 6, I've traveled -3 over 6, which is a -1/2. That can help us get some points in between as they're fairly far apart. So if I went down 1 over 2, you'll notice we get that nice, again, point of intersection on there. And that gives us a nice answer then, where we've gone over to 4, up 1, and we have a solution point of 4, 1, the solution to our system. Now, probably the most helpful way to solve any system or try to graph that system is to get it into y equals mx plus b. That is always a great first step. So go ahead and record the system right here on this next page. Try solving it for y and graphing and see if you don't come up with a solid solution to your system. Once you think you have the point, don't forget, approximate the solution and check your answer. See if you can come close to or right on that right answer. Pause the video now. Alright, so you'll notice that I've taken both of the equations in our system, solved them for y in each instance. For the first one, I had to go up to 13, so it made the graph fairly large, but I used the -2 slope to go ahead and move down 2 units at a time and over 1. Also, I just went ahead and found a point far out here to the right. I plugged in 6, which gave me -12 plus 13 was 1, which was a nicer point than our 6.5, our x-intercept out here. But that gave me a nice blue line there. I drew a nice straight line. Then I went ahead and did the second equation, which I drew over here in red. Again, I had a slope of 5 halves, or 2.5. Had to also start off at a negative half. So from negative a half, I went up 2.5 over 1, and then drew a nice straight line, which means that the lines crossed kind of in the middle of nowhere. It looked approximately like I was somewhere near 3, but I thought maybe 2.27 or 3.7, maybe even 3.8. It was pretty hard to tell. So I took all three of those points down here at the bottom, went ahead and checked them in equation 1. The first one of the three that actually came out and worked in equation number 1 was 3.7. 6 plus 7 comes out to 13. So I plugged that into the second equation, it also worked, which means that that is the solution to my system. Remember, whatever point you find needs to make both equations true, and the best way to do that is check it algebraically. Plug it back in. Now, just a quick reminder for you that systems don't have to come out to one simple solution. If they do, we really like that. That's exactly one solution when two lines just cross. It's technically what's called a consistent system. It has a solution, and it's independent. It has one answer. But the most important thing to remember is that it just has one solution. You could also have infinitely many solutions. It could be a consistent system, but be dependent, which means that basically both lines are the exact same line. They intersect everywhere. So you have an infinite number of solutions. So the best thing to do there is if you notice that they're both the same line, you can just label that as infinitely many solutions. And then the last way is if they're parallel. Remember, two lines won't cross when they're parallel. They will have the same slope, but they won't have the same y-intercept. If they're parallel, that's what's called an inconsistent system, or basically a system that has no solutions. So a great way to notice that, even without graphing, is if we take this first set of equations, and we go ahead and solve for y, you'll notice if I take that first set and I divide everything by -4, that you actually come out to 24 divided by -4, -6x, and 4 divided by -4 is a -1, which is exactly the same as our first equation, which means that if they're the exact same equation, they're going to be in the exact same spot on the graph, they're going to intersect everywhere, and you're going to have infinitely many solutions. Infinitely, sorry, and that will be your final answer. Then over here at the right, notice the same idea. If I take that first equation and I solve for y, y will be equal to a -3/4 x plus 5. But if I solve the second equation, that's 8y equals -6x plus 4, and y equals, if you divide everything by 8, well, we do get a -3/4, 6 over 8 is 3/4 x, but if I divide 4 by 8, you get a 1/2. Again, same slope, different y-intercepts, which means parallel. Therefore, if they're parallel, there's no solution. They are not going to cross. Hope that helps you identifying kind of the special situations. Again, the most important thing, or the ones we really like, are when they come out to one solution. So make sure you graph those and look for that point. Be sure to be checking your answers. Have a great day and good luck solving systems.